I wanted to see if it was possible to make a model maglev train work and actually be able to float using magnets. When I was researching maglev trains, I realized that there were 3 different requirements for them to actually work. They needed levitation, propulsion, and a guidance system. A maglev train can achieve levitation by having magnets of like poles on the bottom of the track and on the bottom of the train push the train upwards. A maglev train can also achieve propulsion by having magnets on the side of the track and on the side of the trains push the train forward. A maglev train also requires a guidance system. The guidance system normally has 2 beams on either side of it and the levitation and propulsion system built into it. When I started researching the maglev trains, I actually didn't know how they worked, but after I did some research, I figured that I could make a maglev train model work and levitate using magnets that could hold up the train using opposing forces. Done researching on how maglev trains worked, I figured it was time to build a track and a train. At first, I didn't really know what I was doing, so I just made a track out of wood without a proper guidance system. Because I didn't have a good guidance system, the train couldn't keep upright, and it kept on falling, so I had to redesign the track multiple times. In the end, I came up with this track, which has a built-in guidance system on the train car, as you can see here. Unfortunately, I could not include a propulsion system, so all the train can really do is float. But because of its guidance system, it has a lot harder time to fall over. Meaning, it can stay upright, and if it had the proper propulsion system, it could work exactly like a maglev train. While I was researching maglev trains and how they worked, I had to also research how magnets worked. Magnets can achieve repulsion, which lets the maglev train float by having like poles repel. When constructing a track for the maglev train, you have to have all the poles face the same way on the track. When you make the train, this rule also applies to it, which then allows the train to float above the track. In conclusion, you can make a maglev train model work by using just a couple of supplies such as magnets, Legos, and some tape. Although I could not make a proper propulsion system for the train, I'm sure if I spent a little more time figuring out how to make a proper track, I could have done it.
Rethink your drink. I answered the question, what drink has the highest amount of sugar? I used Mountain Dew, Pepsi, root beer, Gatorade, Starbucks coffee, water, and sugar. My predictions before I started to research was Pepsi or coffee would have the highest amount of sugar and water would have the least. Diet Mountain Dew has 1 gram of sugar. Pepsi has 69 grams. Root beer has 71 grams. Gatorade has 21 grams. And coffee has 46 grams of sugar. Water has 0 grams of sugar. Sugar is very bad for you and has many health risks. Sugar can cause cancer, diabetes, heart disease, damaged blood vessels, joint pain, and many more things. Sugar can also give you depression and a fatty liver. Sugar will make you gain weight and will cause mood swings. In conclusion, I discovered that root beer has the most sugar with 71 grams and water has the least amount of sugar, 0 grams.
So the question that I wanted to answer was, how do different liquids affect the rate at which the dye on Skittles dissolves? And I knew that some type of physical reaction was going to occur, but I wasn't sure exactly what that was. And a physical reaction is when the molecules of a substance rearrange, but the chemical composition of the substance remains the same. And I knew that a chemical reaction wasn't going to happen because the Skittles aren't changing into something else. They're still staying the same. They're just losing their dye. So I had to do some research to learn more about dissolution because that's the main process of this experiment. And dissolution happens when a substance in a solvent or a liquid forms a new solution. And polar substances only dissolve in solvents made of polar molecules, while nonpolar substances only dissolve in solvents made of nonpolar molecules. And this is because polar molecules have a charge that pulls them toward each other, while the positive molecules mix with the negative molecules, they cause dissolution. And then nonpolar molecules have positive and negatively charged poles in them that are opposite each other, and they pull toward each other, and that causes dissolution. So that's the reason why nonpolar molecules don't really mix with polar molecules, because they don't have the same process of dissolution. So after learning that, I did some research and found out that one of the ingredients that I'm going to be using, one of the solvents, which is vegetable oil, is actually a nonpolar substance, while all of my other ingredients are polar substances. So I was interested to see what would happen when the Skittles mix with the vegetable oil. After I did research on dissolution, I looked up the ingredients of Skittles, and Skittles are made mostly of sugar, corn syrup, color, dye, and then flavoring, but they also have carnauba wax, it's a vegetable wax that comes from carnauba trees, and it's known for its hardness and its high melting point. And the reason it's on Skittles is because it's like the outer shell, and it keeps the Skittles hard, but it also helps them to not melt in your fingers. So I knew that in my experiment, the carnauba wax was also going to have to melt in the solvents before some of the dye could come off, because there's dye under and on top of the carnauba wax. So that was really interesting to me. So some of the ingredients, well, these are all the ingredients that I used, all of the things. So I had used bleach, I used vegetable oil, I used Diet Mountain Dew, I used vinegar, I used warm water and lemon juice mixed with water for my solvents. And then I used 5 cups, one for each color of Skittles, and then I used Skittles and a timer. So basically, how my project worked, how I conducted the experiment, was I took each of the 5 colors of Skittles and I put them in every liquid. So I did it all separately, so each time I had 1 Skittle in a cup of whatever liquid I was testing, because it was easier to find out the accurate times that way. And so first I tested each color of Skittle in water. And these are some of the pictures. So this is what it looked like earlier in the process. As you can see, just a little bit of the dye was coming off, and then this is later in the process as the Skittle is completely white and all the color came off. So during that process in just water, the red Skittles took 112 seconds, the orange Skittle took 153 seconds, the yellow Skittle took 135 seconds, the green Skittle took 140 seconds, and the purple Skittle took 143 seconds. So the red Skittle, all the dye came off the fastest, and the orange Skittle took the longest for all the dye to come off. So after I tested all my Skittles in water, I tested them all in Diet Mountain Dew, and this is what it looks like. As you can see, it's green, and there's some of the dye coming off. And so in Diet Mountain Dew, the red Skittle took 135 seconds, the orange Skittle took 159 seconds, the yellow Skittle took 166 seconds, the green Skittle took 164 seconds, and the purple Skittle took 145 seconds. So the red Skittle, all the dye came off the fastest again, and this time the yellow Skittle took the longest. So after that test, I tried vegetable oil, and as you learned earlier, the vegetable oil is a nonpolar substance, while the Skittles are made of polar molecules, and clearly they did not combine at all. This was after an hour of sitting, so I decided that we were just going to cut this test because it wasn't really going to work in our graphs, but I still conducted the test and found that something really interesting, which was that they don't combine at all, and after an hour, the Skittle remained exactly the same. So I don't have times for that because it never actually completely dissolved the color at all. So after that, I did vinegar, and this is what it looked like. As you can see, there was like bubbles that formed in the vinegar that like made spots on the Skittle. So I didn't count like the parts where there was bubbles. I just counted when all the rest of the dye came off because the bubbles like wouldn't pop. And so for the red Skittle, it was 162 seconds. The orange Skittle took 212 seconds. The yellow Skittle took 184 seconds. The green Skittle took 207 seconds. And the purple Skittle took 169 seconds. So in total here, the red Skittle was also the fastest again. And then the orange Skittle took the longest. So after that, I tested all of my Skittles in bleach, and this is what it looked like. And for the bleach times, the red Skittle took 238 seconds, the orange Skittle took 243 seconds, the yellow Skittle took 239 seconds, the green Skittle took 150 seconds, and the purple Skittle took 213 seconds. So the green Skittle was over 50 seconds faster than all of the other ones, which was a big outlier in all of my data. So that was the fastest there. And then the orange Skittle took the longest. Then lastly, I tested all of my Skittles in lemon juice. And this is what it looked like really early in the process. And so the red Skittle took 68 seconds, the orange Skittle took 77 seconds, the yellow Skittle took 84 seconds, the green Skittle took 84 seconds, and the purple Skittle took 93 seconds while in the lemon juice. So as you can tell, that was by far the fastest test for every color of Skittle. And I found out that lemon juice has a pH of 2, and since it has like natural acid, it took the color off a lot faster than anything else because clearly the Skittles, the dye came off a lot faster in the more natural ingredients than the unnatural ingredients, which almost preserved the color. And so this was all the Skittles after they had been in the lemon juice. And as you can tell, the Skittles that were in there longer, because I tested them earlier, part of the Skittles are dissolving, which shows how strong the lemon juice really was. And so the color was completely off very quickly. And these are some of my graphs. So this was the graph of all the data. So these were all the liquids, and then here's the colors, and then the times. So the colors I don't think affected my data very much. It was more about the liquid. And then here's the mean and the median of all of the colors of each liquid. And then here is the chart, which shows that in the lemon juice, the mean and median were way lower than anything else, and the mean and median were pretty close for each of my tests. So after all of this is over, we found out that my hypothesis was partially correct by saying that the vegetable oil would take the longest because it actually didn't work at all. And the lemon juice mixed with water was actually the fastest test, which I did not predict, but it shows that the natural ingredients did a lot better on taking the dye off than the unnatural ingredients. And so I predicted that the yellow Skittles the dye would come off the fastest, but actually the red Skittles, the dye came off the fastest in 4 out of the 5 of the tests. And I thought the purple Skittles would take the longest for the dye to come off, but actually in 3 out of the 5 tests, the orange Skittles took the longest. So I'm assuming that this is because each Skittle's color, the dye, is made with different ingredients, which kind of affected how the dye came off. So all in all, I don't think color affected my test too much, but it was a lot more of the liquids and how natural the ingredients were. And it seemed to be that the ingredients with more sugar or carbonation took a lot longer to take all the dye off. And so, all in all, I think that's it. Yeah, that's all. So thanks for listening, and bye.
What I wanted to do with my science project is to see which of the three batteries I got, Duracell, Energizer, and Kroger, would last the longest. I did this because I always see that Duracell is more expensive than all the other batteries. I'm like, why is that? So I decided to test it out and see which one lasts the longest. So what I found is that the Energizer costs $5.49, Duracell costs $5.59, almost $6, and the Kroger one was the cheapest by a lot, only costing $4.29. This Each pack had 4 batteries in them. So what I came up with, I thought Duracell would last the longest because it was the most expensive. And okay, so what I did was I put one AA battery into a flashlight. They're all the same brand of flashlight, exactly the same, and turned them on at roughly the same time. There's about 5 seconds between when I turned on the first one, between when I turned on the last one, and shine it on a sheet of paper. I started at 9 o'clock in the morning, and I took a picture every 3 hours and see where each one was. So what I found was that the Energizer one did the worst, only going 7 hours. It was between 9 and it ended at 4 o'clock. 4 o'clock. The Duracell one did the next best, going 8 hours, going from 9 to 5 o'clock. It might be backwards for you, but this is the graphs that I made. So what I saw, it was the same brightness from when I started at 9 o'clock until 12 o'clock. And then after that, it just started to go down really fast, the brightness for each of them. So, but the Kroger one, on the other hand, lasted an amazing 12 hours, starting at 9 o'clock and ending at 9 o'clock at night. So it stayed the same brightness for roughly 8 hours, and then it just went down and shut off. So what conclusions I can make is that Kroger is the best brand of battery that you can buy. It has the best value, and it lasts the longest.
I was wondering what the best method would be for removing rust from my wrench, and then I had an idea. What if I looked into it for the science fair? I knew it would be interesting to see what kind of experiments I could come up with. Here's what I'm actually going to do in the experiment. I'm going to fill all these up with the liquid, and I'm going to put a rusty nail into each, and then in 1 hour, I'm going to take it out with these long pliers, and then I'll rate it on a scale of 1 to 10. And 10 is being, like, really amazing, and 1 being super rusty. So, yeah. And it's the same process with this, except I'm going to turn on the electricity when I start, and I'm going to turn it off when I stop. Like, every time. On, off, you know. So, yeah. So when you talk about acids, you should probably start with the pH scale. The pH scale is all based around water. Water has a pH of 7. The closer you get to 0, the more acidic you get, and the closer you get to 14, the more basic you get. So I'm not going to talk about bases, but basically, the further from 7 you get, the more strong you get. Most of the acids I'm using today have a pH of 0. This means that they should at least eat through rust in a somewhat timely manner. So basically what happens in electrolysis is the cathode pushes out electrons into the salty solution, which can carry electricity, and the anode takes those electrons back in. And a reaction occurs whenever the cathode pushes them out, and it basically makes the rust scale off. So my hypothesis is that the hydrochloric acid is going to eat the rust first, then probably the electrolysis, and then maybe the nitric acid then. So let's get into the resources. Here's what I need for my experiment. Ventilation, nitrile gloves, a mask, glasses, distilled water, distilled vinegar, acetic acid, hydrochloric acid, sulfuric acid, nitric acid, 6 glasses, 6 rusty nails, a tank for water, a battery charger, aluminum wire, long needle nose pliers, wire cutters, wood, pen and paper, syringe, fire extinguisher, paper towels, and the phone for recording all the times. So basically, in order for my experiment to be fair, I need to normalize all these percents here. And what that means is that I make them all 40. Like down here, all of them need to be 40. And the reason I do this is so that they all have an equal chance and an equal timing to remove rust. And basically how I do this is I take this 30 here and I divide it by 60%. And what that does is it turns into 18 and 12. And 18 plus 12 equals 30. So basically what I'm actually doing here is I'm removing 60% of the acid and replacing it with water. So that gives me a 40% solution of the acid, but still gives me 30 milliliters of fluid. So I put my nails in and I can immediately notice that the nitric acid is completely eating up the rust very quickly. And the sulfuric acid doesn't really look like it's doing much, but it is bubbling. And the hydrochloric acid is turning yellow and getting very bubbly. The acetic acid, yeah, looks like it's taking it out. Vinegar looks like nothing happened. And water really looks like nothing happened. Alright, so 1 hour in, hydrolysis looks like it's actually removed a lot of the rust. And compared to all of these at least, it's probably like a 7. Nitric acid, it actually dissolved all of it. So that goes to show that it's very, very acidic. Sulfuric acid looks pretty good actually. Probably like a 7. Hydrochloric acid completely removed all the rust. That's a 10. Acetic acid, probably like a 5. Removed some. Vinegar, I don't know, maybe like a 3. Water, and didn't really remove anything. Alright, so sorry for any storms you might hear. It's actually pretty bad outside. This nail and electrolysis actually looks like there's hardly any rust. On camera it's kind of hard to see, but yeah, probably like a 9. Sulfuric acid is removing a lot of the rust, but it actually is kind of eating the metal, I think. I can't really tell very much, but I think it's eating metal. The acetic acid here, it actually looks like it's removing a lot of the rust. There probably isn't much on here. Vinegar, I don't know, not much. Water, almost nothing. So I'd give all these probably a 9 for the vinegar. That's probably like a 6, and this is probably like a 0. Maybe it's not a 6. Maybe like a 4. So yeah, these are all 9. All these are probably 9. So I'll do 1 more hour, and after that, I'm pretty sure everything will be gone. Alright, so I'm on the 3rd hour now, and it seems that almost all the rust on all of them are gone. It's hard to pick up, but there's hardly any rust on all of them. Except for the water and the vinegar. The vinegar, there's still some rust on there. It's probably like a 7. but the water is probably like I don't know, probably like a 3. It got better. So, yeah. In conclusion, my hypothesis was halfway right. I mean, except for the part when the nitric acid dissolved the metal in the first hour. What I can take away from this is that if I want a quick way to remove the rust, I should use hydrochloric acid. If I want a renewable method, I should use electrolysis. And if I want to destroy my tools, I should use nitric acid. I'd say that the best overall method is electrolysis. It may take a while to set up, but when it's done, it'll last forever. Thanks for watching.
Okay, so today we're welcome to my science fair project. Which brand has the most glucose? Obviously by me. The materials I used were jam, Benedict solution, 5 beakers, boiling water, wax pencil, which is this what is this little black thing right here, and then some tongs. They weren't those tongs, and just all the jam. So those are all the ingredients I used, materials technically. What is Benedict solution and how does it work? Benedict solution is a complex mixture of sodium carbonate, sodium citrate, and copper 2, sulfate pentohydrate. Sorry if I pronounced any of that wrong. Benedict solution is often a replacement for fueling solution to detect the presence of reducing sugars. Put at least 10 drops of the solution into a substance in a tube, and then set the substance with the Benedict solution in it in boiling water for 3 to 5 minutes, and it will change color. Colors that the Benedict solution can turn into and percentages. Blue, because Benedict solution is blue, it will have no solution. Green, it has 0.1% to 0.5% Benedict solution, as you can tell right here. Yellow is 0.5% to 1%, so it would have been in the middle here. Orange is 1% to 1.5%, which is obviously that, very orange. Red is 1.5% to 2%, and brick red is 2% and over, and brick red is obviously dark red like you see on a house. All the jams that I used, homemade, so there isn't really anything you can like go off of it because it is a homemade. Then we have organic Kirkland, so this is an organic brand from Costco. We have Schmucker's, probably the best known jelly ever. We got Hero, this is from Switzerland, and it's like the fancy one. And then we have Food Club, just the basic one that probably everyone has eaten before. My hypothesis. I predict that Smucker's will have the most glucose because it has the most sugar in its serving size. Along with that, it is name brand product, and those tend to be a little less healthy and care more about their taste. So that's what I think. Before being boiled, this is the color. So we have homemade, Kirkland, Schmucker's, Food Club, homemade, Kirkland, Schmucker's, and Hero. So that's in the order. That's before they're boiled with the Benedict solution. You can kind of see the blue. This is while it's boiling. As you can already tell, this is probably 2 minutes into boiling, and as you can already tell, it's already turning like an orangey color. That's good. The results, colors are affected by camera lighting, so if you look at it, it's in the same order: Food Club, homemade, organic Kirkland, Smucker's, and then Hero at the end, as you can tell. And then here's the Google sheet with all the information. Oop. So the name of the jams we have, and then they all had the same serving size, obviously, except for homemade, which didn't have the grams of sugar or anything because it is homemade. And then organic Kirkland had 9 grams. Schmucker's had 12. That's why I said it, because it has the most. Food Club has 9 grams of sugar in the serving size. Hero has 10 grams. And then the color turned. So these are the colors. Homemade turned a darker yellow. Organic Kirkland turned a reddy orange. And then Schmucker's and Food Club both turned a mustardy yellow. And Hero turned a burnt orange. So then the amounts are: homemade had 0.5 to 1%. And then organic Kirkland had 1.5% to 2%. 0, and then Schmuckers had 0.5 to 1%, and Food Club had the same as Schmuckers, and then Hero had 1.1% to 1.5%. So, as you can tell from that little thing, the one with the most glucose in it, or reducing sugar, would be Organic Kirkland. Now, as you can tell, it really doesn't mean anything to it. Like, why would that happen? Because they all are all jams. They all have stuff in it. All of the little beakers had little strawberry chunks. So I don't know exactly why, but I would like to think that it could be because it's organic and they didn't want, it could just be reducing sugars from natural sugars and not just, and maybe, and that artificial sugars don't have as much glucose or reducing sugar because they're that fake. That's my prediction, but then I feel like, yeah, that's my prediction. So, was my hypothesis correct? No, I believe that Schmuckers would have had the most glucose, as I said before. Now I did the test, and Organic Kirkland had the most glucose because it probably has the least amount of, what is that called? Has the least amount of like added sugars, and I feel like Medic Solution usually relies on natural sugar, so that's probably the reason why. And even though Schmuckers had the most sugar in this thing. So, thank you for listening to my science fair project. Hope you enjoyed it. It was really swaggy to do. I had fun doing this project because the experience was fun, and you gotta do a cool like science fair thing, and you gotta do all this cool stuff. So thank you, and have a fantastical day.
For my science fair project, I looked at which sports drink would be the most beneficiary for your hydration and calorie loss. I looked at 3 different drinks: Gatorade, Naked Juice, and Body Armor. I then had me and my older brother do 2 different activities for 3 times. We did biking, lifting weights. I then looked at if it affected our heart rate, reaction time, the amount of push-ups we did after, and overall how we felt, if we felt energized and replenished. Although you may see these come in different shapes and sizes, the Gatorade came in 32 ounces, the Naked Juice came in 15 ounces, and Body Armor came in 12 ounces. I then decided to measure each drink out to 12 ounces to have it fair for all the drinks, so no drink would be benefited more. And after doing these activities, the biking, for me, the best drink was Body Armor. I lost a total of 318 calories plus the drink. So the drink is only 90 calories. I burnt off the drink and 318 calories. So that's 408 calories burnt in a 1 hour bike ride, which is really good. I thought I felt good, I was replenished. And then I did the most push-ups with Body Armor 2, which was 35. So I thought I had some energy. My average heart rate wasn't really affected. It was 142 beats per minute, since biking is a vigorous activity. My hypothesis was that Gatorade would rule all these drinks. Like, it's used by all the professional athletes. It's full of electrolytes to keep you energized, and just overall good drink. Although while researching, I realized Gatorade has a lot of sugar. And for it to be beneficiary for you, you need to work out longer than an hour. For the drink to be beneficiary. So after an hour usually working out, you lose electrolytes and you sweat a lot.
and you sweat a lot and you start to lose energy. Gatorade helps you stay hydrated due to the electrolytes. But although it has 10 calories in it because it's Gatorade Zero, it has less calories than Body Armor. I thought, wow, Gatorade is really gonna rule them all because it has only 10 calories and the other ones had 90. Well, Naked Juice has 220 calories. I didn't suspect much of Naked Juice because it is full of fruits, not any electrolytes. Also, it has a lot of sugar. It is more of like a shake and morning drink, so didn't really think like it would do anything, as my studies show. And coming in last place, Naked Juice. I did the least amount of push-ups with this drink because I don't think I was energized or hydrated. The total amount of push-ups was 16 after biking and 10 after lifting weights. Although after lifting weights you are sore, I think that's why the amount was lower. But along with the Gatorade was the second best. I did feel replenished and like a little thirsty at times, but it was overall a good drink. With biking at 29 push-ups and lifting weights at 20 push-ups. And then we have our winner, which should be the most beneficiary, I feel. I wasn't suspecting much. I really just heard about it doing my project. I was like, maybe I can do something I enjoy. And then I looked up energy or sports drinks, and I never really heard of this one. And I tried it out, and I was like, wow, kind of reminds me of Gatorade, but a little different taste. So after drinking the Body Armor before the workouts, I realized I felt really good. My body was like, I did 32 push-ups after. My heart rate didn't change a lot, which I didn't suspect anything my heart rate would change at all because these drinks aren't energy drinks. They're just sports drinks to help you keep hydrated. Yeah, thanks for watching.
What I did for my science experiment was what kind of food the rabbits like to eat the most. Most people feed their rabbits like pellets and grass and vegetables, and I usually feed my rabbit hay and grass and clover and alfalfa, little branches and corn. And I thought that all rabbits would like alfalfa, clover, and green ants taste the best because they seem to like to eat that a lot during the summer. For my experiment, I gave my rabbit and my sister's rabbit green ants, lace, motherwood, corn, dandelion leaves, clover, and alfalfa. I also gave them wheat and oats. Neither of them seemed really interested in the wheat, but that one ate the oats a little. But my sister's rabbit dumped both of them, so I don't think really interested in them. After I fed them those, since she liked the cracked grass, the green ants, lace, the red clover, I also tried giving her some red clover with the red clover and giving her this kind of grass with the cracked grass to see which one she would like best, and she liked the cracked grass out of this grass and the red clover over the white clover. So I gave her motherwood with the green ants taste to see which one she likes best, because she seems to like both of them, and she seemed to like the green ants taste best. And then with alfalfa, hay, and red clover, she liked the alfalfa and clover both the equal, so I guess she likes red clover, alfalfa, and green ants taste the best. And my graph shows how much food was left after an hour. Because she didn't have much alfalfa, red clover, and grass and dinner line leaf left, she ate them all. But she has some corn left, but she had that even by morning. And she has some wheat and oats left, but she ate all the oats too. And my sister's salad was basically the same, but she dumped her wheat and oats, I'm pretty sure.
For this project, I wanted to find out if men's and women's products are actually different and if their price differences were necessary. Many women struggle with the fact that women's prices are always hiked up, and with research, I found that it was much more of a problem than I thought. Not only are the prices higher for hygiene products, but they're also a lot higher for toys, which is really stupid. Like children's toys. And everyday items such as clothes. My hypothesis was that the women's prices were going to be a lot higher, which they were, and that the women's products weren't going to be as good, which I don't know why I thought that, but I did. And I used these men's and women's deodorants, these for women's shampoo and conditioner, this Dove men's shampoo and conditioner 2-in-1, and these shavers. And I use them how I normally would in a day because, well, I wanted to see the best results. And I wrote down how they performed and how they worked for me. And so I actually, well, the women's products worked a lot better than I thought, and they worked better than the men's, except for the deodorant. That was the only thing that worked better for the men's, which was interesting and definitely didn't really agree with my hypothesis. And there definitely is a difference with men's and women's products, but the pricing difference shouldn't be that high, and I don't know why that is. It's basically just for the packaging is what I read. So that's my report.
Okay, Mr. McMillan, we've got Science Experiment 101. Right, Seth?
Yeah. Oh, it's really going.
It is really going.
I don't think it'll touch the newspaper though.
I hope not. So tell them what you did.
Alright, so I took a candle and I skewered it with a nail, and then I lit both sides. So then when it turns one way, this candle, this flame can burn more of the wax, therefore releasing more matter, so then this side becomes lighter and it goes back up. So now it's just going back and forth.
Very cool. You're brilliant. I think you get an A for the semester. Your mother gives you an A. Since I'm homeschooling now. Well, I'm not homeschooling. I'm just proctoring. Well done.